Hi Year 2, in today's video we're going to look at some extra reasoning questions that we can practice over the weekend. Let's get into it. This is a paper I've printed from online, but as we go through it there'll be questions I cross out because there's some topics we haven't done in Year 2 yet, so there's no need to worry about those yet. Okay, let's start with this one. Janice has 9 small dolls. There are 15 in a full set. How many more dolls does she need to complete her set of 15 dolls? I know this question quite well. We actually looked at something similar today. These keywords, how many more, tells me that I am looking for a difference. I'm just going to write that here. I'm looking for a difference. My keyword being difference. It's really deceptive at first because we think that more means I'm going to add. But actually, whenever we are looking for the difference between two numbers, we always subtract. I'm going to just do a little symbol there just to remind me. Let me just reword this in my head so I know exactly what I'm doing. Janice already has got 9 small dolls. She's got her 9 dolls. There are 15 in a set. How many more dolls does Janice need to make all of these dolls become 15? I am looking for the difference between 15 and 9. That means how many numbers are in between 15 and 9? Because those are the amount of dolls I need. I need to just put this into an equation. I know in subtraction the whole always comes first. My whole is 15 here because that's in a full set and it's my bigger number. I'm going to subtract my part, which is 9, and that's going to give me the answer. Using my number bonds, I know that 15 take away 9 is 6. I can also do that quite quickly because 15 take away 10 is 5 and 9 is 1 less. Okay, so sorry about that. 15 take away 9 is 6. Janice needs 6 more dolls to complete her set of 15. Okay, let's have a look at the next question. Here are 41 balls. We've got 24 rugby balls and 17 footballs. Complete the addition and subtraction calculations below. Let's start here. Something add something else equals 41. I know in addition, a part and a part make a whole. Something add something makes 41. Well, my question actually tells me that. Here are 41 balls altogether. 24 of them are rugby balls. 17 of them are footballs. A part and a part gives me my whole. 24 rugby balls add the 17 footballs equals 41 balls altogether. Now I want to do a subtraction. Wait, I actually can use this equation here to help me. Subtraction is the inverse of addition. And in subtraction, we always start with our whole, the bigger number. In this equation, 41 is my whole. That's the biggest number. That means 41 take away a part will give me 17. Well, I've already got my part. It's here. A part and a part make a whole. A whole take away a part will give me my other part. 41 take away 24 will equal 17. Okay. I need to match the name of the 3D shape to the correct shape. This is drawing on some of my year 1 knowledge here. Okay, let's see. I've got a pyramid, a cylinder, and a cube. A pyramid. I'm going to start with the pyramid. That's nice and easy. A pyramid, just like the shape of a pyramid that you might see in real life. Now I've got a cube and a cylinder. I remember a cube is a 3D version of a square. It's made up of all these different squares. That's my cube. So this must be my cylinder. Okay. I want to circle the odd numbers. I know an odd number is any number that ends in a 1, 3, 5, 7, or 9. Let me have a look. Does the number end in a 1, 3, 7? Yes, 13, 54, 4. Oh, no, 4 is even. 87, 1, 3, 5, 7, 9. I can use my rhyme here. 1, 3, 5, 7, 9. Odd numbers are just fine. Okay, 7. 1, 3, 5. No, 6 is not an odd number. I can't circle that. 55, 1, 3, 5. Yes, ends in a 5. 90 ends in a 1. 72 ends in a. That's not an even number. Okay, I've crossed this question out because we haven't done fractions. However, a question like this could come up. What is half of 6 counters? I've just drawn them out, and you normally would be given a visual representation. I've got 6 counters here. Half. Thinking back to year 1, I remember half means I am splitting an amount into 2 equal groups. I'm going to draw my groups. Group 1, Group 2. Whatever's in here has to match what's in here. Otherwise, the groups are not equal. Half of 6 counters. Every time I have a counter, I'm just going to cross it out and add it in. Okay, let's start. 1. I'm going to put 1 in. Now, if I've put 1 in here, I need to add 1 in here. 2. 2. Great, they're still the same. 3. Oh, 3. There are 3 counters in each of my groups. I've got 2 equal groups of 3. Half of 6 counters is 3 counters. Great. Okay. Write the missing numbers in this sequence. 67, 57, 47, something. 27, something else. I need to see what the pattern is here. All of my numbers end with a 7. I think it's safe to assume that these numbers will also end in a 7. Let's see. Wait, look here, the tens. The tens are decreasing by 1 each time. 6 tens becomes 5 tens. 5 tens becomes 4 tens. 4 tens is going to become 3 tens because 4 take away 1 is 3. So my number here is going to be 37. Now I've got 27 and I want to find the number that's next. I need to subtract another 10. 27. So 2 ones becomes 1 1. I'm subtracting by 10 each time. Great. Draw an arrow to show 75 on the number line. Oh, I've got 60 all the way to 80. And I've got these lines. I think, first of all, to help me, I'm going to find the midpoint between 60 and 80. 60 and 80. 60, 70, 80 if we go up in our tens. 70 is the multiple of 10 that comes in between 60 and 80. Now I can just look here. I want to find the number 75. 75 is greater than 70, but less than 80. Oh, I remember this. If I've got 2 multiples of 10, that's numbers ending in a 0. I know if it ends in a 5, that's going to be in between those numbers. This here must be 75. That's the midpoint between 70 and 80. Let's go to the next question. Cakes are sold in packs of 10. How many cakes are there in the picture above? Oh, I need to use my knowledge of my 10 times table here. I've got 10 cakes, another 10, another. So I'm doing 10, add 10, add 10, add 10, add 10, and then I've got some left over. I've got 10, 20, 30, 40, 50. That's 50 cakes. Add on these remaining ones, 51, 52, 53, and 54. There are 54 cakes. We haven't done this, it won't come up. We haven't done that, it won't come up. I'm trying to think. This will not come up. Here are some 2D shapes. Write the name of each shape in the column below. I want shapes that have 4 sides and shapes that do not have 4 sides. Let's go one by one. Let's see, how many sides does a triangle have? It's got 1, 2, 3. Oh, a triangle has 3 sides. It needs to go in this column. It does not have 4 sides. What about an oblong? 1, 2, 3, 4. It does have 4 sides. I'm going to write it here. I've got a square. 1, 2, 3, 4. Yes, it does have 4 sides. And I've got a hexagon. I already know that a hexagon has 6 sides. It needs to go here. It does not have 4 sides. Okay, we're going to do one more. This is a good one. We're not going to look at these two, but okay, and ignore that. Tick the calculations that are correct. 9 add 4 is the same as 4 add 9. I actually know that's true. That is correct because addition is commutative. So I know that I can swap my parts around and still get the same answer. 9 add 4, just to check, is 13. 4 add 9 is also 13. That's correct. Let's look here. 9 subtract 4 equals 4 subtract 9. Hey, that doesn't make sense. Can I have an equation that says 4 take away 9? I can't because my whole needs to go first. And my whole is 9. That's my greater number. No, I'm not going to tick that box because it is not correct. Okay, I'm going to pause it there, but I really hope this video helped to go through some reasoning questions together. If you have any more questions you'd like me to work on, please do let me know. And in the meantime, hope you have a lovely weekend.